I mentioned earlier that there are two primary reasons for factoring polynomials. And one is to solve equations, and we're going to look at that now. And the other is to be able to simplify rational expressions. And so the solving aspect is uses factoring as a technique. And it works on polynomials that have a degree that's higher than 1. Now, this problem, solve x squared plus 5x minus 6 equals 0, is known as a quadratic equation. And it's a second degree polynomial. That means the highest degree term is a 2. So the technique here is if your trinomial, in this case it's a trinomial, is equal to 0, set equal to 0, then our technique is to factor it as a first step. So let's go ahead and factor this. And we have x's go here. And what about the 6? All right. And I know you can kind of think of that in your head, but I like to put this down here when I'm teaching this stuff. And I think when you're factoring, if you have a little trouble factoring, the more information you can put down in front of your face, the better it's going to be for you. You don't have to think quite as hard if you have information in front of your face. So anyway, what should it be? 2 times 3, 1 times 6? Well, probably 2 and 3. So let's try that. See if that works. And let's see. It looks like it will because I get a 5, don't I? I have 3x and 2x. That's 5. To get a plus, you're going to have to be pluses. All right, so is that factored correctly? I hope you're thinking no. What's the problem with this? Why is this factored incorrectly? Well, because even though we get x squared, and then we get plus 5x, we also get plus 6, not minus 6. So this can't work because I'm supposed to get a negative 6. And if I change one of these signs, for example, if I made this a negative, then I would no longer get a 5 in the middle. I would get, for example, here I would get 3x minus 2x is 1x, not 5x. So anyway, that pair doesn't work. So I'm going to erase it. By the way, 6 is a fascinating number. These are the factors of 6, 1, 6, and 2 and 3. If you add up 1, 2, and 3, you get 6, which is the number. And so 6 is a number where if you add up its factors less than 6, the sum of those factors equals to 6. There's another number like that. 28 is a number. If you add up the factors of 28, which are, let's see, what would it be? 1, 2, 7, and 14, right? Oh, no, 28. The factors of 28 are, 1 and 28, 2 and 14, and 4 and 7. So if you added up those factors, 1 plus 2 plus 4 plus 7 plus 14, it'll equal 28. And now the next number like that is around, I think it's around 492. It's in that range. It's in the 400s. And the one after that is in the 8,000s. And those are special numbers. I know I've digressed a bit, but I always like to tell us the classes. Numbers that have that property are called perfect numbers. And there are only about 30-some perfect numbers known. And most of them are huge and had to be determined by a computer. But we know how to find perfect numbers. At least we know what they tend to look like. What no one has ever found is an odd number that satisfies that property, an odd perfect number. It's not known if there is one. And so it's one of those unsolved problems in mathematics that people are still working on. It's not important to our world that anybody finds an odd perfect number, but it's important in mathematics because when you solve neat problems like that, you tend to uncover other kinds of facets of mathematics that people didn't know about. All right, so where was I? Okay, so anyway, I hope you found that little digression kind of interesting. We excluded 2 and 3 as a factor in pair, so let's try 1 and 6. 1 and 6. And can I get a 5 out of that? Well, yes, I can get a positive 5 provided that I have a plus 6 and a minus 1. So you can check that, and it factors correctly, or it multiplies back correctly, this is x squared. Plus 6x minus x is plus 5x, and then minus 6. So this is factored correctly. And now what do we do with it? Well, in order for this product to be 0, what has to take place? If you want to think about it this way, I'm multiplying a number times a number. Think of these parentheses as a number. And if I multiply two numbers together and get 0, what has to happen? One of those has to be 0, doesn't it? Have you ever seen a product of two numbers that equals 0 where both of these numbers were not 0? I have, but not with real numbers. Okay, I have in other kinds of algebraic systems. But in the algebra systems we use for ordinary numbers, more particularly the real numbers, that never happens. And so it's an axiom that in the field of real numbers, so as a mathematician might call it, that the product of two numbers that equals 0, one of these has to be 0. That's called the zero product property. Let me write that out. The zero product property. Again, I'll state, I don't want to write it all, write out the definition here, but if a product of numbers, it can be integers, rational numbers, irrational numbers, complex numbers, real numbers. If a product of two numbers gives you 0, then at least one of these numbers has to be 0. Alright, so and there's only two choices up here. Either this number is 0, x minus 1 equals to 0, or this number is equal to 0.